Hello friends, in today's lecture we are going to understand about sign convention, mirror formula, only the definition and the mathematical equation of mirror formula, then magnification for mirror, also we are going to have a concept of refraction and refraction through glass slab. Okay, so first let's start from the first topic, that is sign convention. Okay, first of all, what does this sign convention means? Is there any other name for this type of sign convention? So yes, we can understand it and we can call it that it is Cartesian. It's Cartesian's sign convention, and according to this sign convention we will know that how we can consider the positive or negative sign for distance of object, distance of image, height of image or height of object. Okay, and that will be very helpful to us to calculate the sums. Okay, according to the sign convention for a spherical mirror, here we are going to understand the Cartesian sign convention for spherical mirror. In such cases, first point is all of the terms are considered by pole P, means all the, here we can write down this is pole P. So all the distance is taken with reference of pole P. One more important thing to note here is that always object is always placed to the left of the mirror. Okay, so here we can see that object is always placed left of the mirror. Now according to this sign convention, all the distance is taken with the reference of pole P and object is always placed at left side and the pole P. Okay, now consider that suppose if we take our object is here, right, and if we get the image somehow here like this, so how to consider it? Okay, so suppose this is my object distance u, this is my image distance v. Here suppose we are having principal focus f, so this is my f. So remember, always suppose this is height h of object and image height is h dash. So it is always clear that the distance which is left to pole, okay, which is left side of pole, that is always taken as negative. Means the distance which is left side to pole on x-axis, that is always taken negative, and the distance which is right to pole, which is at right side of pole on x-axis, that is always taken positive here on x-axis. So distance on x-axis, left side to the pole is taken negative and right side to the pole is taken always positive. Second thing, distance which is measured on y-axis, here this was our x-axis, so also we can consider with the reference of pole P that this is our y-axis and this was our x-axis. Now the distance on y-axis, how it is taken. So the perpendicular distance will be, if perpendicular distance is taken above the principal axis, perpendicularly above the principal axis, and the another way is which is taken perpendicularly below the principal axis. So the distance which is taken perpendicularly above, so see here this object distance, it is above the principal axis, so this object distance is always taken positive, and the distance which is below the principal axis, okay, here you can see the image is below the principal axis, so this image is taken as negative. So this will be our concept, right? So again just revise it, all the distance is taken with the reference of pole P. Here we can have a y-axis and x-axis. All the distance, right, which is at left side to the pole will be negative, right side to the pole will be positive. Upside means above the principal axis will be positive, below the principal axis it will be negative. Okay, after understanding Cartesian sign convention, now we will try to our another concept is of mirror formula. So let us understand that what is called mirror formula. Before that mirror formula, we have to understand some terms also. So mirror formula, for mirror formula we know that the u, that is called object distance, and what it is distance of object from pole P, okay. V, which is our image distance, that is distance between our image and pole P. Suppose here we can take it like this, that here if we consider, if we want object distance, so we have kept our object here, so this distance pole P and the object, that is our u, here the image is formed, so this distance that will be considered as our v, image distance, right? So pole and object, distance between that is object distance, image and pole between that is our image distance, and this we know that distance between P and F, that is our focal length, okay. So this F, it is our focal length, means it is distance between principal focus F and pole P. Now what is mirror formula? Actually mirror formula, it is a formula, right? It's a formula which gives a relation between u, v and f. So mirror formula is a formula which gives us relation between object distance u, image distance V and focal length f, and generally that relation for any of spherical mirror, it is given like this. It's a reciprocal of image distance plus reciprocal of object distance, right? Sum of reciprocal of image distance and object distance is always equal to reciprocal of focal length f. Okay, here for sums also we can use this formula, that r is equal to twice f. Okay, so this 1 upon v plus 1 upon u is equal to 1 upon f. This is our mirror formula, and here when we are using this formula we have to understand the sign convention, and during sums we have to when we are forming the ray diagram, during that how the image, where the object is placed, according to that we have to take u, v or f, positive or negative, by using sign convention. Okay, so this is our mirror formula. Next concept, okay, is magnification by spherical mirror. It's very easy concept, magnification. Here from the name you can understand that magnification means the image, how it is magnifying, how many times it is magnifying. To know that we required a new term, and that is magnification, right? We can note this magnification as m, and this magnification, it is defined by a ratio of height of image to ratio of height of object. So we can write like this: magnification f is equal to height of image by height of object, and this will be negatively signed, because we know generally for spherical mirror we are getting real and inverted image, so we are taking here minus. Or we can also derive it like this, that magnification m is equal to image distance and image distance by object distance. From this we can write down their formula. Suppose height of image, that is h dash upon h, right, minus sign, and here image distance, that is v, so minus v by u. Okay, so this way we can derive it. Okay, this u v sign or h dash and h sign, we can use sign convention according to the cases, and we can find out the magnification. Now it's very interesting that we will have different cases for magnification. By that we will know our image will be enlarged, same in size, or diminished, how. Okay, so for that magnification we will have three conditions: m is equal to 1, m is greater than 1, and m is less than 1. And it's very easy. M is equal to means height of image and height of object both will be same, then and then we can get m is equal to 1. So here we can say that our image h dash will be equal to h, right, both will be same. Okay, in second case, if m is greater than 1, so when this magnification can be greater for this ratios, when your h dash means our height of image is more, right? So when h dash is greater than h, and we have seen that in case of image formation, in case number 4, 5 and 6, in that we are getting enlarged image, right, magnifying image, so that will be considered here. So when your height of image is greater, in that case m magnification will be greater than 1. And the third is When magnification is less than 1, it is simple that when the denominator is bigger than the numerator. So in such case your h dash will be smaller than h. Okay, so by this value we will know that how our image is. Also, the magnification can be positive and negative. So if the magnification is negative, so always remember our image, it will be real and inverted. And when our magnification is positive, always remember that our image will be virtual and erect, right? This information is very necessary to understand the nature of image. Suppose if I say that I am getting a magnification value, it is m is equal to, I am getting -3. So what does this mean? Minus sign means our image will be real and inverted, but this 3 means that it is greater than 1. So my height of image will be 3 times more than my height of object. Okay, so this way we can interpret the nature and size of images. Now we will have the another concept, and it is also a very most important concept, that is concept of refraction. Let us understand that what is called refraction and the terms which are related to refraction. Okay, now as we have studied that in reflection the light is bouncing back. Generally 3 type of phenomena are possible for any of light when it strikes to the surface. It is partially absorbed, it partially reflect, and it partially refract. So first of all, what is refraction? Okay, suppose if we have 2 different medium, okay, transparent medium, and this is a surface which separates 2 medium. Suppose this is our medium eta 1 and this is our medium eta 2. We are having 2 different transparent medium, eta 1 and eta 2. Our concept is of refraction. Now what will be definition of refraction of light? Okay, so it's very simple that when any of slanting light ray, when it passes from this one transparent medium to another transparent medium, actually this is the path of that light. But when any of light, it passes from one transparent medium to another transparent medium, this is normal drawn to the surface, this is our incidence or incident ray, right? So when light ray, it transferred from, this is one transparent medium, this is another transparent medium. When light ray enters from one transparent medium to another transparent medium, it will change its direction. Now there are 2 possibilities. It may change its direction like this, or the another possibility is here also. Suppose this is the original path of it, this is the normal drawn to the surface, okay, like this. So these are the 2 possibilities. This will be normal drawn to the surface, this is our incident ray. So here also we can understand that when a light ray enters, in both of the case light ray enters from one transparent medium, here also we are having eta 1 as this first transparent medium and eta 2 as this another transparent medium. When light travels from one transparent medium to another transparent medium, it changes its direction. So see, this was the direction of light, but here in both of the case this was the original direction of light, but light ray, it has changed its direction. So these phenomena of changing its direction is called refraction. So how we can define refraction, how we can write refraction? So it's simple, that change in path, we can write like this: change in path of a light, change in path of a light ray, okay, when it is changing its path as it passes from one transparent medium to another transparent medium, is called refraction of light. So refraction of light means change in path of a light when it transferred or when it passes from one transparent medium to another transparent medium. Okay, when this type of case will happen and when this type of case will happen, let us understand. This is case A and this is case B. Okay, now here we will have two possibilities. In first possibility, you can see that the refracted ray, this is called our refracted ray, okay, refracted ray. Okay, so which are the possibilities when case A will happen and when case B will happen? It's very simple. Here you are saying that the refracted ray, it is moving towards the normal, and here you are saying that it is moving away from the normal. So here it is moving towards the normal, and in this case refracted ray is moving away from the normal. So when case A will happen and when case B will happen. Okay, first of all, try to understand that case 1 or case A, when this case A is going to happen, when our eta 1 means first medium, it will be rarer and the another medium, it will be denser, right? So if your eta 1 means first medium is rarer medium and eta 2, that is our denser medium, means when light enters from rarer medium to denser medium, it will move towards the normal. We can also understand it like this: R D T, means rarer to denser towards the normal. Okay, and the another case, case 2 or case B, if our eta 1 is denser and eta 2 is rarer, means when light enters from denser medium to rarer medium, it will move away from the normal. Here we are seeing that this is the normal, right? In this case it is moving towards the normal, and in second case it is moving away from the normal. Okay, so here we can write it like this, that D R A means denser to rarer medium, it will move away from the normal. Okay, so it is very simple. Here we can do it like this, that suppose this is a denser medium, so we can show this like this, that this is a denser medium, and here eta 1 is a denser medium, so we will try to make it visible like this. Okay, so this will be easy to understand us, right? So rarer to denser towards the normal and denser to rarer away from the normal. The concept of refraction, we can see that a pencil which is pen, the above medium is of air and the another medium we can see that's of water, right? So here the bending of pencil is seen because the light which is entering in our eyes, it is reflected back, but here the phenomena is done, that is refraction, because we can see that light is entering from the medium of air to medium of water, and that's why we can see this type of refraction. So let us understand that what is concept of refraction. Now we are going to understand refraction through a rectangular glass slab. Okay, here we have a rectangular glass slab. When light enters in this type of glass slab, here this is a first surface and this is our first surface, and this is our second surface, right? Here we know that this will be a medium of air, this will be medium of glass, and again it will be medium of air. So this is our first medium, eta 1, it is of air. The another, this medium eta 2, it is of glass, and this third medium, it's again eta 3, which is same equal to eta 1, that is of air. So see, when light enters, this is now rarer medium, this will be our denser medium, and again this is our rarer medium. So when light enters from rarer medium to denser medium, so in this first surface refraction will take place. Also this is denser and this is rarer, so here also refraction is going to take place. Now let us see how refraction is going to take place. This is first our ray of incident, okay, and we are also drawing its path, its original path, right? Okay, so this is the original path if refraction is not taken place. Okay, as we know that here I will draw the surface, normal drawn to the surface. This is rarer, this is denser. So when light enters from a rarer medium to denser medium, here we are giving name to this surface AB. So at this surface AB, light enters from rarer medium of air to denser medium of glass. So from rarer to denser, RDT, it will move towards the normal. So here we can see that our light ray, it will move here towards the normal. Okay, it has moved towards the normal. Now for this surface, we are considering here this surface as C and D. So at this surface, what is going to happen? Now this is our incident ray. In this case, it makes angle I. Here it will make angle R. Here we will draw normal drawn to the surface. This will be also our angle R. Okay. Here we can see that when light ray was moving from rarer to denser medium, it has turned towards the normal. Now for this surface CD, this is our incident ray. At this surface of separation of two medium, this is now our denser and this is our rarer. So it will move away from the normal. So in this case, our light ray, it is going to move away from the normal like this. Okay, but one more thing to note down here is this both rays, it will be parallel. Okay, now let us understand. Suppose here I am writing this angle as E. What was this? This was my incident ray. This is my refracted ray, and this ray is our emergent ray. Here you can see that this is the original path of our incident ray and this is our emergent ray. Here we will have three different angles. First is this angle I. So that angle I is our angle of incidence. Angle R, that is our angle of refraction, and angle E, that is our angle of emergent, right? So angle E, that will be our angle of emergence. Here we can say that when a light ray enters in a glass slab, okay, so this is our original direction of incident ray and this is our emergent ray, and that will be parallel to each other. Means we can say that our incident ray is shifted, and this distance, how much it is shifted, this distance is called lateral shift or lateral displacement. Now what is lateral displacement? We are also going to study it in detail. So we can assume like this, that this was our assumption that light is going to pass like this, but when it passes it was like this. So here we can assume that our incident ray is shifted, right? And this distance, how much it is shifted, that is called lateral displacement. Okay, so what is the definition of lateral displacement? We can say like this, that the perpendicular distance between the emergent ray and incident ray when the light passes out of a glass slab is called lateral displacement. So here it's very clear, we don't have to go for proof of it. Okay, incident ray, it will get refract towards the normal because rarer to denser medium. At the second surface, this is denser medium, so when it comes to rarer medium, it will move away from the normal. Okay, but in this case, the original direction of incident ray and the emergent ray both are parallel, and how much they are shifted, that distance is our lateral shift. So this distance is considered as our lateral shift. Okay, we can give the explanation of this whole phenomena, that we have taken glass slab A, B, C, D. At surface AB, our incident ray is moving towards the normal. At surface CD, it will move away from the normal, and as shown in figure, we are getting the emergent ray which is parallel to our incident ray, and that parallel distance, okay, so the perpendicular distance, this perpendicular distance between the emergent ray and the incident ray, that is called our lateral displacement.